My neighbor decided he wanted a wood stove, so we bought 2 sheets of quarter-inch plate, 4x8, and designed the stove so it used all of the material. This is what we came up with. There's a door with a damper. The company I was working for would send me out of town every week for 5 days, anywhere from Florida to Ottawa, Canada, and just about every state in between. And the first winter, Hill and I just fired the stove as you see it. And when it was getting too hot in the house, she and I would close the damper completely off here, and it would put the fire out because this was an airtight stove. Only way air can get through is through the damper and out the stovepipe. And while gone, Hilda was having a hard time keeping the fire going because this from here to here was 30 inches, and it's hard to get wood that far back in the fire chamber. So I came up with the idea to put stokers on the stove, and that way I could load it. It would last the week I was gone, and 90% of the time when I got back, it would still have at least half of the wood left. And I added a stoke on the front and on the back. In order to keep the putting the fire completely out, I drilled about 6 quarter-inch holes in this damper, so if it was completely shut off, it would still allow just enough air, ambient air, to get into the chamber and keep a few hot coals going without heating the house up too much. I figured if I put these stokers on there from here to here, with 7 foot 6 inches, with the stokers and the burn chamber together, it helped about 3.3 cords. Of course, my wood wasn't really that seasoned. Around here, we got more species of hardwood you shake a stick at. We mostly burn oak and hickory. I see on YouTube where a lot of the wood processors stack and store the oak up to 2 years before they sell it, before they can get the moisture content down. But with this system, I wasn't really worried word about the moisture content, because you got to remember two things about heat. Heat rises, and heat always travels to cold. I learned that when I joined the local volunteer rescue squad. I was in that for several years. One of the first classes they taught us that heat travels to cold, because if you come up on a victim laying on the frozen ground, you always try to get something warm between them and the ground, because the cold ground would, well, the heat from their body would travel to the cold ground, and they'd get hypothermia pretty quick. But as I filled these stokers up with wood, this front stoker, I would start out with smaller rounds. Anything 12-inch and under, I would not split. I would just put it in hole, and time it fed itself. Self-feeding gravity is a wonderful tool. As this turned to ash, it would just keep dropping down. And as I put the wood in, of course, some would fall down, fall back this way. And same thing here. They would meet up. With the front stoker, it would burn out first, because fresh air would come in and burn this wood. And everybody asked me, so how in the world do you keep it from burning all the way to the top? It never got enough oxygen to get up into the self-feeders. The highest I ever saw the flame would be get just to the top here, and that's where the flame would stay. You hot coals and burning. And as this stoker fed itself out, that left all the fresh air to come and travel back into this area, and this area would burn. Then time I got back home, all I had to do is most times about 75% of the wood was still left in this area. It was just like almost like charcoal time, and by the time this one burn out, this one then bake this wood and leave zero moisture. I would just fill this stoker back up, and as this one burnt down, it had enough space on each side, a couple of inches, for the air to get past these rounds of wood and continue to burn back here. But there again, you got to remember, heat does two things. It rises and it travels to cold. While this was burning, some of that heat would rise up in this stoker, because it's cold wood, the heat's traveling to the cold, and time this one burn out, this one be good and cured, ready to burn. Then I'd come back and refill this. One of the most often questions I got, people would ask, why didn't the smoke just come up through these stokers and out into the basement? And I told them I had a lid on both of them, airtight lid, where it wouldn't leak. And the reason it never burnt up into the stoker because it didn't have enough oxygen to burn. It depended on how much. You could have a damper wide open, and it would only get up to the bottom of the stokers. This is my second attempt of making this video. Yesterday, I uploaded it, and everything showed up reversed. All my writing was backwards, and it showed me making my drawing in reverse. So I had to take that one down and attempted it again. I pushed all the buttons the 17-year-old told me to push. It uploaded, but everything in reverse. Took a while for me to figure that one out. Come to find out, the camera was set up for selfies. I wonder about them things. And you had to push the off button for selfies because when it came from the factory, it was set up for taking selfies, which makes it look like you are looking into a mirror. So I unchecked that, and hopefully this time everything will look correct. With this 3.3 cords of wood loaded in the stove, we're trying to capture all the BTUs we can to heat our home. That's approximately 15 million BTUs. So that's a lot of heat. And it did a wonderful job. Out of the years I've used this, I've never had to clean my flue. What little Crisco that gathered in the flue just flaked off and fell down to the base of the flue where I had a clean out door. And over the years, I probably get a gallon of flakes out of the base of the flue. So it was clean and burned. It burned clean. For the past 2 years or so, I've been laid up after having so many heart attacks and kidney problems that I watch basically every YouTube video on hot water boilers, hot water furnaces really, and people processing firewood. That has to be some of the most dedicated, devoted people on the face of the earth. Feeding those stoves 2 or 3 times, boilers, furnaces 2 or 3 times a day, and the folks processing firewood, my hat's off to them. I believe I know them all by heart after watching them for 2 years or better. But the docs have got me pretty well on the way, and I'm feeling good now, getting my strength back. I can walk around my house 3 or 4 times now without having to sit down. So I decided to design an outdoor hot water furnace. And the main purpose I had in mind was to help people eliminate the heating bill and domestic hot water bill. I designed the outdoor hot water furnace where you would only have to load it about every 2 weeks, and remove the ashes at the same time. I was trying to eliminate all the doors. You had to clean, a lot of cleaning. And with this one, way I've got it designed, the only thing you got to clean is clean the ash from the ash bed. And once you lift the lid off the hot water furnace, all you have to do is just stack your wood in the burn chamber, just like you're stacking it to cure, to dry out. Because the better you stack it in there, the more you get it. Just throw it in and throw wood in willy-nilly, and you're losing about 25% of your area. The good folks feeding their stoves 2 or 3 times a day might want to put the lazy britches on one day and just take it easy. I also built into this hot water furnace some chambers where you could put containers of your favorite wood to make charcoal, whether it be hickory, oak, pecan, wild cherry, apple. Has all different flavors, and you could market it if you wanted to as a specialty item, because the chunk charcoal you get out of the store, it says on the bag mixed hardwood. You really don't know what you're getting. And another thing about chunk charcoal, 1 pound of chunk charcoal equals 2 pounds of briquettes. I don't know whether people realize it or not. Anytime you cook with briquettes, you're cooking with coal oil, cooking that into your food, and several other chemicals that they use to bond the briquettes together. So if you like your food being cooked with chemicals and charcoal dust, that's up to you. With a 1 quart of wood you put into the burn chamber, that's 43 million BTUs. Our goal is to capture as many BTUs we can that will transfer into the hot water. And two, on this furnace, I've designed it with a dry chamber. With a dry chamber, the chamber will stay hot enough where the crisp, so if it does get on, it'll dry and flake and fall back down into the fire bed and burn. If you decided to fill the chambers with containers of your favorite hardwood or even wood chips, the wood chips would turn to biochar grade charcoal. There's another sideline if you want to pursue it. Or if you go on eBay, a 5-gallon bucket of biochar is $68. If you decide to use the charcoal chambers, that'll be another additional 15 million BTUs. That's all for today. Hats off to everyone. Hope you having a great day. I'm gonna try to put up another video tomorrow going in more detail how to design this outdoor hot water furnace. Thank you very much.